Okay, lots of different lab topics, and I tried to rename some of them for you because some of them look like the same thing. This is a list as opposed to a group of pictures here for models or slides in this case. And then our lecture today is on the heart. Okay, traditional PowerPoint. Don't like it, but it'll get us through. It'll get us through pretty fast. I've edited this PowerPoint anyway, quite a bit. It'll be more to our liking. It's actually a summary of chapter 19, the one that you're looking at or beginning to look at now. It's on the heart, which is considered, and yes, you got PowerPoint in front of you, you can't help but read it. I'm trying to rearrange some of the words. The heart is two pumps side by side. The right half is shown over here in blue, meaning it's deoxygenated blood primarily going through there. And the left half is shown in red, meaning oxygenated blood is primarily in there. Okay, the right side of the heart pumps deoxygenated blood to the lungs, where at capillaries in the lungs and in the alveolus, oxygen is taken up and carbon dioxide is dropped off. The oxygenated blood now continues back to the heart and is pumped forcibly through the rest of the body until it reaches the capillaries of the tissues, where the exchange in the opposite direction takes place. The oxygen is given up and CO2 is taken up, and the CO2 taken up goes back as deoxygenated blood to the heart. When we say deoxygenated or we say oxygenated, it doesn't mean 100% one way and 0% the other. Okay? It's just a relative statement. The heart's about the size of a fist. I didn't get the space in there, and weighs about 3/4 of a pound, 10 to 12 ounces. The number of beats per day is, I put here 115,000, but that depends upon who you are and how many, what your resting heart rate is, okay? What's anybody's resting heart rate? Anybody know the resting heart rate?
Fast.
Oh, fast?
Yeah, for me at least, a little faster than normal.
Yeah, I'm talking about in beats per minute.
Mine could be like 80. It's on the higher side.
Okay. And actually, it can go up to 100 before anybody gets worried about it, I think. Anybody higher or lower than 80? There's going to come a time in your life when you're going to know all this stuff about yourself. Okay, trust me. Anyhow, mine has always been 66, and once in a great while 60, and then I wonder if I need to wake up. Okay, the heart's located in the mediastinum, or actually that's my old pronunciation for it. The correct pronunciation is the mediastinum. That's the area behind the sternum, okay, and it's between the two lungs. So this area roughly here is the mediastinum. At the top, it's wider, and at the base, it's apex, it's narrower. Okay? The top, the wide portion, is the base. We have a triangle here, and the Y portion is the base. The point of the triangle is the apex, and the apex of the heart then points roughly down and to the left. It's set in there at a roughly 45-degree angle, a little different for each of us, of course. And it's surrounded by one of the serous membranes we talked about, the pericardium. The pericardium is shown in white here. It actually has two sides. The visceral pericardium will hug the heart itself, and then outside of that is the parietal pericardium. The pericardial sac is in between the two and has pericardial fluid to lubricate the heart as it moves. Not a difficult drawing. This shows the.
Charlie, I actually have a quick question.
Yeah.
So like with the AED, how does the electric current like affect the heart? Because I know you're supposed to put it on top of it and then on the side. And so my question is like, how does the electric currents like, is there a specific way, like, why do we need to put it on the side one and then like on top of the heart? If that makes sense.
It makes sense to somebody who knows the answer. I don't know the answer. Okay, sorry about that.
It's no problem. I think so.
Okay. I told you, the first rule of teaching, if you don't know the answer, you say so. Okay, so I said it. The pericardial sac is shown here, and it's not a great drawing, I don't think, but here's the sac. It's white, and then it curves around. This is the parietal pericardium I have the needle on right now, and here's the visceral layer, or the visceral pericardium. The visceral pericardium hugs the heart wall. The visceral pericardium is also known as the epicardium. Epicardium. Okay. If I don't mention something, I don't consider it that it's very important. I mean, I wrote it all yesterday, but I don't always write important things. The outermost layer of the heart, okay, where I'm touching here, okay, that's the visceral pericardium. That's the one that's known as the epicardium. When we cut into the heart, we'll cut into the muscle, which of course is cardiac muscle, and that muscle in the here, even here, all the muscle underneath the epicardium is called myocardium. It's thicker on the left side. This is the left side of the heart, because the left ventricle has to contract so forcefully as to push the blood almost through the entire body. It gets some help from the veins. We'll talk about that later. The innermost layer, the inside here, the inside here. As blood travels through the heart, imagine that it were India ink. As it travels one rotation through the heart, it's going to stain a lot of things. Everything it stains is the inner wall of the heart, or derived from the inner wall. And all of that material is called endocardium. We have the outside envelope, we have the muscle, and then we have the inside lining. Okay, I told you this the other day, but bears repeating. It's definitely going to be a test question. Arteries carry blood away from the heart under high pressures, and the blood is considered to be oxygenated most of the time. In this PowerPoint, it doesn't give me any flexibility. It says it's oxygenated all the time, but we do have a couple of instances where blood in an artery is not oxygenated. Okay, one we'll get to right away. Veins carry blood towards the heart under lower pressures, and the veins carry back deoxygenated blood, or blood that has less oxygen in it. The vena cava, and the plural is with an E on the end here. Okay. I'm used to, and you are too, to see vena cava. Okay, but the vena cava bring blood back to the heart. Here's the superior vena cava. Here's the inferior vena cava. They're both coming back. We can't see the entrance here into this top chamber, the right atrium. We will in a moment. Okay. Then the superior vena cava brings blood back from the upper part of the body and the arms. And the inferior vena cava brings blood back that has circulated through the lower part of the body. The pulmonary trunk is a major vessel that carries blood from the heart to the lungs. Here's the pulmonary trunk. We're going to see in a moment that the blood that entered in from the vena cava to the right atrium went down to the right ventricle and then out through the pulmonary trunk. The pulmonary trunk subdivides into two pulmonary arteries. Here's one, here's the other. These pulmonary arteries in the pulmonary trunk are carrying deoxygenated blood. So immediately they are a contradiction, or that's not the best word. I think a better word is an exception to the rule that arteries always carry oxygenated blood. They do not. Okay, the pulmonary are deoxygenated. They want to go to the lungs and pick up the oxygen. The pulmonary trunk branches into the right and left pulmonary arteries. Returning from the returning from the lungs, once the blood has been recharged with oxygen, the blood returns by means of 4 pulmonary veins. Here's one, 2, the other 2 are on the other side coming behind. They're entering into this structure, which is the left atrium. Sometimes we get a specimen and we only find like 3 of these pulmonary veins. And the reason is it was cut too close. And the entrances for these 2 that I'm pointing at have become one entrance. Okay. We won't be fooled by that. Again, pulmonary arteries carry deoxygenated blood, and the pulmonary veins carry oxygenated blood. So both of these are sort of different from our normal perception that arteries carry oxygenated blood. It's not always the case. Here are the major cardiac blood vessels. The aorta leaves the left atrium. It's right here. Curves up in what we call the aortic arch. Immediately we have 3 large vessels coming off. And these, if selected by the blood going through, will transfer the blood to the arms and the head and all the rest of the upper body. Blood that doesn't make it through one of these 3, it continues on and goes downward and will go to the lower body. The very first thing that the heart will take care of is itself. It doesn't care about your right arm. It doesn't care about your ear. The heart cares about itself first. If it doesn't deliver oxygenated blood to itself, first, well, then it's not going to function. If it doesn't function, nothing functions. So as blood goes into the aorta, there are two openings, one showing here, the other not showing on the other side, but coming out here. And these are going to the right coronary artery and the left coronary artery. The arrow is not pointing at anything because it's behind the pulmonary trunk here. So the very first thing that gets oxygenated blood from the heart is the heart itself. We have 4 chambers for the heart. I'm sure you all remember that. Okay. The atria, of which there are 2, are on the top, on the left and the right. These 2 atria beat simultaneously and have flaps for extra storage of blood associated with them. These are called auricles. Let me see if I have a picture of that. No, great PowerPoint. Didn't have a picture of that. Okay, the atria, when I say they beat simultaneously, the atria receive blood. The right atrium receives blood from the vena cava. It also receives blood from the coronary sinus, which is the return of blood that has circulated the heart surface, and it goes around the back and drops into the right atrium. Okay. They're showing the coronary sinus here, and what they're showing is the blood coming back deoxygenated now, going around behind the heart. Okay, that's why they draw it light, and it comes back and re-enters the right atrium. So there's 3 entrances to the right atrium: superior vena cava, inferior vena cava, and the coronary sinus. Can you hear my phone ringing?
Yeah.
Not much
Yeah.
I don't want to do anything about it because I'm afraid of losing our connection. So I've got it on low. And you know, it's nobody I know because I don't know anybody. All I get is spam or whatever you call it. Tons and tons of it. Okay, the chambers of the heart also include 2 ventricles below, left and right, 2 chambers. They beat simultaneously. Well, what's all this bit about beating simultaneously? The 2 atria up above, if you had your hands on 2 balloons and you could squeeze them at the same rate, same pace, that would force the air or the water that you might have in those balloons downward. And in our situation, it would go into the ventricles. The ventricles themselves have to be more forceful. They are going to push the blood into the pulmonary trunk and to the lungs, or even more to the whole body through the aorta. When the ventricles contract, they do so really, really fast and hard, and again simultaneously. Septa. Septa are simply walls that separate chambers. The atrial septa separates the left and right atrium. Okay. And the IV septum, this one here, is the interventricular septum. Interventricular separating the left and the right ventricles. The atrioventricular septa is the septa that goes right across. Just lives up to its name. Let's look at this for just a second. This figure of the heart. The vena cava brings blood back. The vena cava inferiorly brings blood back. That enters here, and it enters here. This does not show the coronary sinus, which is a small hole that is right there. That's bringing blood back from the coronary circulation. Blood then passes from the right atrium through the valve, the tricuspid valve. It's got three cusps, three sides to it. Those are all attached to the ventricular wall by these cords. The cords are called chordae tendineae, tendinous cords. And they are attached to muscular outcroppings of the ventricular wall. You can see them here and over here and here. These are called papillary muscles. When the blood enters into the right ventricle, it's next primed to go up through the pulmonary trunk and pulmonary arteries to the lung. And when the ventricles, both of them, contract forcibly, it forces that blood up into here. Why doesn't the blood go back the way it came to the right atrium? It cannot, because the valve, the tricuspid valve, can only, under pressure, it will close. It will close back up, and it won't blow backwards. It can't, because of the chordae tendineae holding it like strings or ropes. So the tricuspid valve is expected to close securely and not let blood go backwards. If it does let blood go backwards, if any of the valves do that, then we have a murmur. When the blood goes up to the pulmonary trunk, it did so because the right ventricle contracted forcibly. Now the right ventricle is going to relax, okay, and allow more blood to come in from the right atrium. But in relaxing, wouldn't you think that the pulmonary trunk, being under pressure from just receiving a whole bunch of unexpected blood, would push that blood back? And it would, but it can't because of the valve here. This is the pulmonary semilunar valve. It has three sail-like parts. Only two are showing here. And when the blood tries to go back, the sails open and capture the blood. And the harder the blood tries to come back, the tighter the sails or cusps get, and the blood does not go back. Okay. Oh, I'm sure a drop or two leaks back, but nothing to speak of. Well, there's still pressure here in the pulmonary trunk. The pulmonary trunk has just received a burst of blood, and if it can't send it backwards, it'll send it forward. The pulmonary trunk is an elastic artery. We used that term in the last talk. It's an elastic artery. It expands, and then when the pressure is off of it, it contracts and forces the blood forward. Okay, so now we've got the blood going to the lungs, which are not part of the diagram, of course, and it'll come back through the pulmonary veins. Here they are, 1, 2, 3, 4. They enter into this chamber, the left atrium. Only 2 of the entrances are showing, the other 2 are over here. This is sort of a boring chamber. Nothing really going on there, just collecting blood. But it's oxygenated blood now. And now this blood will go down into the left ventricle through the mitral valve. The mitral valve is often called the bicuspid valve in high schools and such. I like you to still know the 2 words, mitral and bicuspid. Blood goes down here, and now it's going to be forced out by ventricular contraction. And when that happens, the blood will be forced back up, but it can't go up because the mitral valve closes. It has 2 cusps. In the heart, there are 4 valves. The mitral valve is the only one with 2 cusps. All the rest have 3. Now, the blood now is going to exit. It's got to exit somewhere. Can't go back up, so it goes into the aorta. And as it goes into the aorta, they're showing just a little sliver here of the aortic semilunar valve. It's a mirror image of the pulmonary semilunar valve with 3 cusps. The blood goes past it, inflates the aorta. At the relaxation phase, the aorta tries to push it back but can't because it goes into the cusps of the aortic semilunar valve. There are 3 cusps of the aortic semilunar valve. As I said, there's 3 cusps of everything except the mitral. In the aortic semilunar valve, 2 of the cusps have a small hole in their bottom. Okay, think of them as cups, coffee cups, rounded coffee cups. And you have 3 cusps to catch the blood, but 2 of them have small holes. And those small holes lead right into the right and left coronary artery because the heart takes care of itself first. Okay. You can tell when I'm getting ready for a test question. I say it over and over again. Okay. The heart takes care of itself first. The blood now comes up, and it has a chance of going into these structures here. You'll learn about these later. They're not labeled now. They're the brachiocephalic artery, left common carotid artery, and the left subclavian artery. Don't have to worry about that now. Okay? But the blood that passes by those goes down, and the artery, the aorta, travels behind the heart. And again, since it's not listed here, you don't have to worry about it now, but it's for the future. It's the descending thoracic aorta. And this will pop through the diaphragm and get to the lower body and bring blood to all parts of the lower body. These to the upper body. Okay, everything that I just said is repeated right here. Everything here is repeated. Okay, somebody needs to turn their mute on. I don't want to go back and find it. Okay, this shows how the valves work. Blood coming through. Now when blood is trying to go backwards, here's the left ventricle. Blood being forced into the aorta, but also being forced up against the left atrium. And when that happens, this closes and is held in place by the very faintly distinguishable chordae tendineae. If the chordae tendineae weren't there, these flaps would completely go backwards and be totally useless. The semilunar valves, some refer to them as half moons. The semilunar valves are getting a name change, it seems, in some of the books, but I think I see the ones that we are using coming back. The pulmonary semilunar valve would be located right here. It's also called the pulmonary valve these days. I will always use pulmonary semilunar. Here's how it opens up. Blood going, say, for instance, into the trunk, pulmonary trunk, and then when it drops backwards, it drops into these troughs and closes the cusps of the valve.
I have a quick question, Charlie. Are heart murmurs like painful?
What being painful?
Heart murmurs.
Oh, heart murmurs? They can be, but most heart murmurs aren't painful. Most people don't know they have them unless they are doing exercise, and the murmur itself is large enough to cause them problems. Just then it would be painful. But just sitting at rest, most no.
Okay, thank you.
Okay, here's the pathway of blood through the heart. We've already said it, but it bears saying one more time quickly. Venous blood, that's the oxygenated blood, comes back to the right atrium from the vena cava and the coronary sinus. I added that in there. We haven't had a picture of coronary sinus offered up by this PowerPoint, so I owe you a picture of coronary sinus. You'll get it. In fact, you'll get it in the second half today. Okay, the blood flows through the tricuspid valve and down into the right ventricle. And from there, the blood flows to the pulmonary semilunar valve and into the pulmonary trunk and to the pulmonary arteries, to the lungs. Once oxygenated in the lungs, the blood returns by way of pulmonary veins into the left atrium. And from there, blood flows through the mitral valve into the left ventricle, and from there through the aortic semilunar valve. It goes up to the aortic arch, where it gets a chance to go to the head region or to the lower part of the body. In either case, it exchanges oxygen or gases at the tissue level. Okay. This is sort of a diagram of exactly what we just said. I don't think there's anything more to say. Okay. PowerPoints can include actual photographs, of course, and images and other things. This one didn't. This was provided by the sellers of your book, okay? And I decided to use the PowerPoint myself because I was running out of time yesterday. That little quiz that you're going to take next, that little quiz kept falling apart. I kept getting lost with it. I can't believe it was so hard to put together. I'm now looking forward to next week, where I got to put a 100-point practicum together for you. Oh well, I'll get it done. Okay, so I'm backing out of this. Here's the idea with the bonus quiz. There'll be 10 photographs of the models, the human models, okay? And a muscle will be indicated either with an arrow or a star. I believe that's all I've used, okay? And without saying it, I want you to, in your mind, of course, identify it, but that's not what we're looking for in the answers. In the answers that you pick, I decided I only want the action. You look at the muscle and give me the action, okay? And yeah, that's one of the things I had to do. I was going to have the origin, insertion, and all the action in there, but it was too hard to separate them in the time that I had. So I thought, well, give them the action. That'll be good. Okay, so you're going to look at 10 muscles. I haven't set it so that you cannot go back, but going back is probably going to take up your time. You are only going to get, hang on for this, I upped it too. I'm giving you all 3 generous minutes. 3 minutes to take this test. If you don't know one, the suggestion is guess. You got 1 chance out of 4 of getting it right. You ought to get at least 2 points on this test if all you did is guess throughout the whole thing. Okay, but of course I'd like to see a lot higher scores than that. There is not time to go back and forth. There's not time to linger on one question that's giving you trouble before you go to the next. Get the next done. In fact, if I were going to take the test and one of them's giving me trouble, I'd pick my best answer real quick and mark it, okay, and maybe flag the question to come back to if I have time. I expect most of you will run out of time. That's okay, and there's no apologies. This is extra credit. This is not the real test. I wouldn't do that to you on the real test. Okay, now, what I would like you to do, if you're following my screen, okay, I hope it works. And I've never done this before, and I haven't heard of anybody else trying it. If you have, let me know. You'll see what I'm going to ask in just a second. But I want you to go to, not now, in a moment, go to the modules when I release your screen anyway. Go to the modules, come down to week 8, and at the very bottom, you don't have it now in case you're looking. It's extra credit models, week 8, worth 10 points. It's the very last thing. I will activate it right away here when we're ready to start, but nobody should be able to see that right now. Now, when I activate it, okay, you still are in Confer Zoom. See if you can take the test. Okay, in other words, you will start the test. Mine is a preview, of course. You'll start the test and take the 10 questions. Submit the test. After you submit the test, see if you can go back to Confer Zoom. Okay, and you can log back in, but I'm going to give you a break. If you get kicked out of Confer Zoom, work the test and get it submitted. It will pre-time you at 3 minutes from the time you open it, and it will cut you off at 3 minutes. So try to go back into Confer Zoom. If you get kicked out, then you know how to get back in. Just go to Saddleback, Canvas, log in, all that stuff, and then come to Confer Zoom once again and rejoin. Okay. Now it's 2:49 right now. I will open the test in just a second. I got to go back to the modules. You don't have to rush to get over there, but I don't want you to linger. Again, I said that word too many times today. I don't want you to stall. I want you to get over and start the test. Like I said, it starts timing when you begin the test. That doesn't mean you get to begin the test in an hour. You do it, please, in the next few minutes. And I'll start the test, and then I want to see you back at 3:15. Okay? Now time for the test, to look over the test, go take a break, come back at 3:15, and I have some good regular heart models and stuff for you. Okay, the test is ready. I'm going to release the
Charlie,
screen.
so sorry, just really quick. So we're taking it right now, you said, right?
Right now.
Okay.
Okay, I've released your screen, so let me know if there's any problems. I'm waiting here to hear it.
Also, Charlie, just a heads up, I believe you're still recording the session.
Yeah, I don't need to. Thank you. Okay, we're back. Any questions?
All good.
Okay. Some of you were all good. There's a couple of perfect quizzes and a lot of quizzes around 6. Couple of quizzes not quite so high, but any point that you get adds on to next Thursday's practicum. Speaking of the practicum for next Thursday, then it's 100 questions. I'll probably be sending you some more information. I always bother you on the weekend, I know, but you don't have to read it all at any particular time. And you pretty well know how much you know just by this quiz. Some of you don't have a lot of studying to do. Others, I think, have quite a bit of studying to do to get the grade they want, okay, and to have a grade anywhere near the first practicum, which was, as we all know, the easiest practicum. So you definitely not need to set aside time for studying the muscles that we've gone over a bunch of times. Bring with you, if you can, or have them questions on Tuesday. Send questions by email over the weekend if you've got them too. We have one more part to finish for today, and you saw your score. I didn't hear anybody say anything about, oh, that was the wrong answer, it was incorrect or something like that. So I'm going to assume that the test was fine. And I'm not going to post those scores on the internet or send you a score sheet until I add it onto your practicum next Thursday. So, any questions before we go on?
All good.
Okay. Okay, here's where we just were. Now, where we are going to be now is right above it. For 10.8 today, the heart model and specimens lab. Okay. This one was actually put together of this picture by a student. It's a sheep heart, and you're going to see more of them. The heart has nothing to do with next Thursday's test, but we're actually ahead because we had no holidays or anything like that. And so here's a heart. You can see a smaller side on the right. That looks like the left maybe to you, but that's the specimen's right. This is the left, okay? This is the myocardium. Myocardium. The visceral pericardium or outer layer is also known as the epicardium. So epicardium, myocardium, and then on the inside, anything, as I said, that blood would touch moving through the heart is endocardium. Okay. So these are the various layers. You can also see unlabeled the tricuspid valve here, and over here the bicuspid valve. Labeling some different things using the same model. Here's the right atrium, the tricuspid valve, the right ventricle. Now the right ventricle looks really short-changed, like it's very small. Not quite that small. It's the angle that this was cut. Here's the IV septum, interventricular septum, which is totally myocardium. Okay. The apex is the point, the downward point. Here's the left ventricle, the mitral valve, and up here you barely get to see anything of the left atrium. Okay, it's just the way that it cuts. If I were ever to use a picture like this, I would definitely feel free to use any of these labels, but I certainly wouldn't use the left atrium. Okay. A term we haven't had yet, trabeculae carneae, is this thing that looks like a bunch of tree roots in a Cambodian temple. This trabeculae carneae allows the chamber to expand better. Without it, it could actually rip or shred. So trabeculae carneae is in both of these. And if I back up, you can see it here too. This is a papillary muscle. A papillary muscle is one that attaches to the chordae tendineae. The chordae tendineae, which we mentioned, this should be spelled with an H, CH. Chordae tendineae and here are attached to the mitral valve, because this down below here is all the left ventricle. When blood leaves the left ventricle, it pushes through into the aorta. The aorta comes up and around. But here, this little guy here, is the aortic semilunar valve. That's one cusp of it, sort of like one snow cone. Well, we want 3 snow cones together to inflate. Okay, sort of like also a skydiver's reserve chute. Okay, but when we dissect, we're very lucky to get more than one. This is the aortic semilunar valve. This is a model of the heart from the laboratory, and it's been abused a lot, unfortunately, but this one's pretty good. Okay. What's a good starting point? Well, we could start at the aorta, everybody knows that, and that would be the aortic arch here. This is, I said, the brachiocephalic artery. The brachiocephalic means brachio to arm, cephalic to head. So it's going to go in both directions to take blood. This is the left common carotid artery. And this is the left subclavian artery. The right subclavian artery is this one. Blood enters from the vena cava. Here's a vena cava here. The lower one doesn't show. Enters into the right atrium. From that, it goes through the tricuspid valve, shown in plastic here, with 3 parts, 1, 2, 3. into the right ventricle. The trabeculae carneae shows, that's that tree roots that I mentioned. When the blood leaves the right ventricle, it goes up through the pulmonary semilunar valve, pushes it aside, gets up into the pulmonary trunk. When it relaxes the ventricle, the blood tries to come back, but it can't. It opens the three cusps or the three chutes and prevents the blood from going back. This is now going to the lungs. This is a pulmonary artery. And from the lungs, it comes back by pulmonary veins, right here. There's another pulmonary pair of veins. On the other side, we can't see it. Here's the left atrium, left ventricle, mitral valve in between. Where's the aortic semilunar valve? In this one, they didn't take a picture suitable to show it. It's hidden back in here. I think we'll see it in just a second. Okay, many of these may be repeats of the same information shown differently. If that's the case, I'll just barrel on through. The vena cava, right atrium, just looking from the surface now. Okay, here's the right coronary artery, one in red. The right coronary vein is right next to it. Here's the aorta. Here's the left atrium. The pulmonary trunk is here. Apex down here. Here's the left coronary artery. Yep. Nope. This is a different view of the same. Let's see how we make it out. Okay, the top is up here, bottom's down here where it should be actually. Here's the inferior vena cava coming back into the right atrium. We're seeing it from the top down. Here's the superior vena cava coming back to the right atrium. The left atrium's here, receiving its blood from the pulmonary veins. Okay. Here's the coronary sinus. This is blood that is circulated to the heart. Now it's come back, deoxygenated, and it enters into the right atrium right there. This model got busted some time ago. Somebody dropped it, but it's still one of my favorites. Okay, what's labeled here is nothing. The apex is here. The right atrium would be here. The auricle is the flap of tissue that can receive more blood and expand, and it's a part of the right atrium. The right ventricle would be down here. We need to open this to see it better. The coronary sinus, we're on the posterior side of the heart, brings the blood back here, and it and the inferior vena cava are going to empty into the right atrium together. This is a pulmonary vein, another one here. Here's a pulmonary vein, here's a pulmonary vein, and nobody's been able to figure out what that is. So I call it an extrapulmonary vein. It doesn't matter. As long as it works, as long as the organism lives, it doesn't matter. An extrapulmonary vein is not going to hurt a thing. Now we pull the model apart. Okay, the apex is down here. Here's that coronary sinus going back behind the heart. This is the pulmonary, here's the pulmonary trunk. take this is the pulmonary semilunar valve, and swing it shut here. Okay. Here's the tricuspid valve. Okay. This is the three-cusp valve, and so is this. Here is the left atrium, the left side. Oxygenated blood returning from the heart. Here's the mitral valve. Here's the trabeculae carneae and the myocardium. When blood leaves the left ventricle, it goes through the aortic semilunar valve. And we'll go from there up here to the aorta. Okay. This is the pulmonary semilunar valve. This is the pulmonary, not artery, but this is actually the trunk. Pulmonary trunk here. The orientation of this guy is a little confusing at first, but then when you figure it out, you really have figured out the heart. Okay, we've got another guy here we've seen before, but he's got more labels, so let's quickly go through them. Left atrium, IV septum, left ventricle, right atrium, and the auricle of the right atrium. The tricuspid valve, the mitral valve, the pulmonary semilunar valve. The aortic semilunar valve is still deep underneath here and cannot be seen in this model. The chordae tendineae are these little lines, these fibers, very, very tough. And the trabeculae carneae does show on the outer side. The inside is better. Here's the pulmonary semilunar valve again. Here's the mitral valve. To see the aortic semilunar, I don't know why they keep, they made this one so many times because they're not showing it. Okay. Anything we haven't seen here? Well, I told you here's the right subclavian. Here's the brachiocephalic. Here's the left common carotid. Here's the left subclavian artery. These will be rolling off your tongue when we get to the next section. I know you don't want to hear all these words today, and do you have to know them today? No, but the more frequently you hear them, the better they'll sink in. Aorta, superior vena cava, pulmonary trunk, pulmonary veins, and this is the left pulmonary artery. The right one comes out here. On the back of the models, they also have the esophagus and trachea, and we point them out because sometimes people get confused as to what they are. They're trying to make the model somewhat realistic, and they put the trachea and the esophagus behind it. Okay. Any questions? I think you've got plenty to do sometime between now and Tuesday, and then certainly between Tuesday and Thursday. Please try not to cram. Please don't put everything off. It's hard to break habits. I know. The habit I have is always trying to tell people that. So it's hard for me to break that habit. And I just don't know how useful it is for me to say that. But it definitely will help you on this exam. This will be a clean exam. The pictures will be good. It will use the cat. It will use the cat for about 40% of the images, and 60% approximately will be the human. Okay. There will be a very few questions that are multiple choice and just strictly written or text rather than have a picture with them at all. But I wouldn't say more than 10 of those at the outside. But they are all information that we've done in the lab. Okay. Does anybody have any questions? Well, then as people file out or sign out, others usually stay and ask a few questions, and I'll certainly wait and see if that's the case today. Okay.
Thank you, Charlie.
Okay. Goodbye.
Thank you.
Bye.
Thank you, Charlie. Have a good rest of your night.
Okay. You too.
Thanks, Charlie. Later.
Thank you.
Thank you.
You're welcome.
Thank you, Charlie.
Bye-bye, Natalia.
Charlie, the exam you said is some fill-in, correct?
No fill.
Oh, no fill-in. Okay, I misheard you. Okay, thank you. Have a good one.
Okay.